Another fundamental problem for the limited expansion Big Bang model is the formation of galactic-sized structures in the early universe. For example, if we were to take all the stars in every galaxy and compress them all together within a region of space, smaller than a dot, and we take all the galaxies in the entire universe and clump them all together in a region smaller than, let's say, a marble, we have a highly energetic state where the energy is so intense that no form or structure can be maintained. For example, within this water bottle I have some stones. I start to shake this and impart energy, increase the energy content within this bottle, assuming the bottle could withstand the abuse. The stones will start to break down into sand. The sand would break down into molecules. Continuing this process, the molecules themselves would start to come apart. Electrons would fly off. We have a plasma. The nucleus itself would start to break down into quarks. Everything is broken down into its constituent parts, and there is no order or form. Well, this condition is exactly what we would see in the early universe. The energy contained would be so intense within such a small region of space that nothing could be formed. Everything would be moving around in a very chaotic state. The photon would run in a photon. Everything would be smashing into each other and breaking each other down into parts and distributing themselves rather uniformly. Now, this uniform distribution, as it was being carried by the expansion of space and time, would be even further exacerbated by adding the process of inflation, which is another after-the-fact fix used to try and make sure the model conforms to observation, which is another topic entirely on itself. But everything ends up being distributed far-flung, far away from each other. There is no individually clump-sized distributions of galaxies. So how do we end up with a universe which is basically consists of vast regions of space with galaxy-sized clumps of matter distributed more or less uniformly across the universe? There is no physical process or means that this can be done when you consider the limited expansion Big Bang model. Well, my proposed model has a somewhat different beginning. If you just follow the relationships. The universe starts off not as a point of singularity, but as a volume of space and time with a certain size. And at this size, matter comes streaming into the universe, and these clumps of matter will become the galaxies. An example I like to use is that of a basketball. And if we imagine a highly compressed basketball with a highly compressed state, within the basketball represents the initial volume of space-time, how the universe would begin. Of course, we'd have to visualize a four-dimensional space as opposed to a three-dimensional space. And the surface of this basketball is under such high stress that it's pre-stressed. It's ready for a fracture. And if it fractures, it doesn't fracture as like big clumps. It fractures as individual pieces. An example I like to use is that of tempered glass. Tempered glass is made by, you have two sheets of glass, and you have it heated in the interior, and then when you glue it together, you have a contraction which puts the outside of the glass into compression where it's strong, but the interior glass is in tension where it is weak. And when you break the glass, this pre-stressed load causes the glass to fracture in individual pieces. Well, the same kind of pre-stressed condition is what exists when our universe begins, or if I take my basketball analogy, this pre-stressed skin, which would actually be a volume, collapses and cracks and fractures. And these individualized pieces are what enter into our observable universe, and it is this process that results in the distribution we see of galaxies across within our universe. Now, so on one hand, you have a model that has no physical means of explaining why the universe is shaped the way it is in terms of its galaxy distribution, and you have the opposed geometric expansion model that at least gives a reasonable explanation of how this process could occur. I very much appreciate your time in reviewing my work, and I look forward to sharing some more with you, and have a good day.